Now, hi everybody, how are you? Um, I want you to remember now where we were when we were back in class. I had finished volumetric analysis 1 with you. That's acid-base titrations. I had demonstrated them to you, and we had got down as far as here. I think you'll probably recall that, okay? Now, can I remind you, please, that after this unit, this very class I'm doing with you now, I am going to spend the next 2 units going through your exam paper from March. So you're going to need a copy of the question paper. Now, it is an attachment. Will you have it prepared, please? And go and get it ready so you have it in front of you for the next unit, all right? Everybody needs an A4 pad and pen. I keep reminding you of that. You need to go back on some of this, and of course, you can pause any of these videos if you wish to get anything. So please be ready to kind of get up and going with these, and you need to be ready. A periodic table, page 79, would be helpful as well. Keep that in mind, please, won't you? Now, I'm going to get rid of this. That was the early part of volumetric analysis. Let me remind you briefly again as to what we're saying with this. All right, everybody? These are the 4 titrations on your syllabus. I've just done an animation of them there. I'm just checking your screen to see, are you visible with that? Is everything all right? And now, you're looking at 4 titrations there. Let me just run through them briefly with you again to give you a sense of them, okay? You use a primary standard sodium carbonate to standardize hydrochloric acid. I put a question mark when you are looking for the concentration, and I put an asterisk when you know the concentration. And that was 1 titration, and we discussed that already, but I'm going to say to you now that I need to do some questions on it with you. Right? Next, when you've standardized the HCl, you can then use the standard HCl to standardize sodium hydroxide. So you find the concentration of sodium hydroxide. Then when you have standardized the sodium hydroxide, you can use the standard sodium hydroxide to determine the concentration of ethanoic acid in vinegar. Okay, ethanoic acid's concentration you're looking for. When I demonstrated that to you, I had that up there and that one down here. Okay, I'll talk to you about that again in a moment. And lastly, washing soda is the same as number 1. Washing soda is technically sodium carbonate, except you're looking for its concentration and you know the concentration of HCl. Here, you were looking for the concentration of HCl and you know the concentration of that. So they're the only 4 titrations that you can be asked for leaving cert. Now, in our last class, we were using this question sheet. And I'm going to spend some time now working on it again with you. You all have a copy of that. If you haven't, pause the video, please, and go away and get it, because you need to see the question we're working on. I only did number 1 with you, and I am conscious of that. So I'm going to do numbers 2 and 3 with you now. Now, can I suggest something to you, please? These are types of questions. They're not necessarily leaving cert questions. They're a type of question. My function is to try and anticipate the style of question you will get. And I'm asking you now, as you go through this, please, will you be careful that you are working your way through it and that you are making sense of it. Now, just let me dismiss the first one very quickly for you. We did water crystallization already. It came up in the exam paper that you did in March. So I'll be doing another one of them with you, so don't worry about it. I need to do a bit more here with this now on purity. Now, let me talk to you a little bit for a moment about purity. Technically speaking, any one of the 10 titrations on your syllabus could be adjusted on the exam paper so that one of the reagents was impure. And you'd be asked to work out the percentage purity or the percentage impurity. And that's something I'm going to do with you now, and I need you to be aware of that. Now, I realize I'm just throwing some charts up here. These are all in your notes, by the way, if you need them. Let me show you this again for a moment now. These are the 10 titrations on the syllabus. The first 4 are acid-base titrations. After I've finished your exam paper, in a week or so, I will be doing volumetric analysis with you. And you'd have to have the full volumetric analysis complete. You can't do that, of course, without doing this section here on redox, oxidation and reduction. So I'll be doing oxidation and reduction before we could touch this section. I don't think I'll get to that this year with you, but I'm just saying to you that that is water. That part down here would be relating to sodium thiosulfate, and the KMNO4 are redox, and the bottom ones here are water analysis. Now, you have a copy of that already. It's the entire syllabus. Okay, so just concentrate on what you've done and make sure you know that, and you're going to do fine. And we're just working on these ones here, the acid-base titrations. Let me put back that question sheet again for you then, and I'm going to work my way through the solution of these. It's very important for everybody that you can take it and you can go through it and that you can work out the concentrations that are involved in these. Now, I've given you questions here. I'd like you to work with them if you would, please. They are questions that are not necessarily leaving cert questions. They're a type of question. And I want you to know how to adapt when you're asked something like this. I'm dealing with the purity question then, and just bear with me a while. I'm going to read it firstly for you, and then we'll go back and see what needs to be done. 2.8 grams of impure potassium hydroxide is made up to 250 centimeters cubed with water. 25 centimeter cube portions of this solution is titrated with 0.1 molar sulfuric acid solution. The procedure was repeated 4 times, giving the following titration readings. 1, 2, 3, and 4. You're given 4 titration readings, and you're asked to calculate the percentage impurity. Now, I'm only focusing on the calculations here on the volumetric, but I do want to say to you that it's very important for you to make sure that when you're going through this, that there will be a set of other questions. How did you do it? And why did you do it? Okay, but I will deal with them as it arises in exam questions, but I just need to deal with the calculation of this firstly, okay? So I'm going to give you some sense of what you are doing now. Now, you could not be asked that in Leaving Cert. Now, don't let me alarm you with that, but I'm just saying that you could not be asked sulfuric acid and KOH, because they've specified the very chemicals you can be using for Leaving Cert. This is a method, but I want you to adapt. I want you to get a good method so that no matter what they ask you, you'll be able to do it. You're given the equation, you're given everything you need to know in the question, so we're going to work on that. Now, I'm going to animate the question for you, and I'd like to think you do this in the exam. Everybody in Leaving Cert does question 1 on the paper. Okay, over 99% of candidates do question 1. So it's very important for you as an exam candidate to realize you need to perfect this area. And I'd like to think of the 20 minutes you'd spend doing that question in Leaving Cert, that 5 minutes would be spent preparing the answer. And if you do that, I think you'll do very well here. Now watch what I'm going to do here. I'm going to animate it, right? Somebody weighed out, okay, 2.8 grams of impure potassium hydroxide, KOH. That was given to you right there, okay? So somebody weighed that out, okay? It's impure. Some people would weigh it in a clean, dry beaker. Some people would weigh it on a clock glass. But anyway, they would weigh it out. And then you'd obviously dissolve that in water, deionized water, like that, okay? You pour water in there and you dissolve it. And then they've told you it's made up to 250 centimeters cubed. So obviously it's put into a volumetric flask. Now I've done this with you already, so I'm not too fussy about it other than I want to make sure you know what you're doing. That's a 250 volumetric flask, and that's put in here, right? And made up to the mark in the usual way. And that would be KOH, and I'm putting question mark on that because we don't know its concentration. Because it's impure, some of the 2.8 grams is impurity. So our task is to find out what is the percentage impurity, or maybe the percentage purity, same thing. Okay, but you have to recognize that we don't know how much of the 2.8 grams is actually KOH. So you have a solution of KOH, which you need to standardize, whose concentration you need to find out. We don't know it at the moment, and that's the whole purpose of the exercise. Now, how you did that is another thing. I'll recap on it in a moment about technique. You weren't asked that here. You're simply asked to do a calculation. Okay? That many grams then was made up to 250. 25 centimeter cube portions of this solution is titrated with a 0.1 molar sulfuric acid solution. So you've been told that 25 of that is titrated. There is your conical flask. Okay, and that goes in here. 25 centimeters cubed, KOH, question mark. Now, how do I know that's down here? And here's my burette. Okay, I'm just animating that, there's your burette. And it was standardized with sulfuric acid, okay? Sulfuric acid is H2SO4, all given to you now, by the way. Everything is given to you, right? And you're told its concentration is 0.1 molar. So that's a standard solution. We know its concentration, right? We're looking for this, we know that, okay? And they've told us here, given the following titration readings. There are 4 titration readings, and you're asked to calculate the percent. Now, we need to find out the volume of this that was needed to titrate against this to neutralize the KOH, okay? So do you know the rule for getting the average titration? And the rule always is, you scrap the first reading. It's always an approximation. You always put a line through the first one and take an average of the last 3. And of course, it is 23.0, 22.8, and 22.9. So 22.9 is the average. Okay, I'm repeating that again for you now. You always eliminate the first reading because you're working blind. You don't know quite where the end point will be. Once you've got the first end point, then the next time you run the titration, you can be far more cautious and they're likely to be far more accurate. And that's very important just in what you would be doing there, right? And be sure you're just getting through that now. Now, that's very important that you're able to see that and you're able to work your way through that. I hope it's okay. Now, I have nearly everything I want here for the moment. Nobody asked me any questions. I'm going to go back now for a moment before I do the calculation. It's not in that question, but I want to ask you a few things. They'll ask you one procedure for leaving cert. Either how did you prepare that solution, or how did you transfer that solution in here, or how did you prepare the burette for titration, or how did you run the titration? Now, do you remember? That's in your notes already now. They're the 4 commonly asked questions. Not in the question at all. Now, these are all about calculation. But I'm just going to mention briefly to you now. If you were describing how you prepare that for 15 marks now, you would tell me that you'd weigh out the impure potassium hydroxide by transferring it to a clean, dry beaker and placing it on a scales which was already zeroed. Okay, and you would place exactly 2.8 grams of the impure KOH in the beaker using a spatula. Now, when you're describing method here, drop names of bits of apparatus because they tend to be associated with the marking scheme. Okay, you transfer the solid into the beaker, which is up on the scales, and you're doing that with a spatula, little spoon, okay, chemical spoon. Next thing, you would add deionized water, and please say deionized water, to the beaker. And stir it with a glass rod. Don't just say stir it with a glass rod until it all dissolves. Okay, that's what you do. You put in some water, stir it, put in some more water, stir it, and eventually you get it totally dissolved, right? And then you must now wash a volumetric flask with deionized water only. Just wash it out with deionized water, very good. Now, you must say this, using a funnel, pour the contents of the beaker into this flask. Okay, very important. Okay, using a funnel. Now, if you don't say a funnel, you're going to lose marks because there's a very narrow neck on this flask, and of course, it's necessary that you are aware of good method. So, and you continue to wash the beaker and pour the contents into the flask through the funnel. In other words, you want to make sure that every last grain of the 2.8 grams ends up in here. Wash the beaker several times and put all the washings in here. And wait for it. When the liquid is about 1 centimeter from the graduated mark, remove the funnel. Now, if you put it in, you must remove it. Remove the funnel. And finally, using a wash bottle or a dropper, add the remaining amount of deionized water until the bottom of the meniscus is at the mark. And then you stopper it and you mix it. Now, please, make sure you don't leave out any of those details. That's very important. Next thing is, how is that solution converted, transferred to here? It's using a pipette. A pipette must be washed twice, deionized water, and then the solution it's about to contain. Okay, and effectively then you transfer it using a pipette filler, transfer it into this flask, touch it against the inside, and discharge it into the flask and touch it against the inside. You acknowledge a tiny drain of liquid is left in the jet. This is not included in the 25 for the pipette. Now, it's not shown here at all. I'm only mentioning that to you. That would be a question in its own right. Either that or that. Prepare a burette. You wash the burette twice. You wash the burette twice. with deionized water, and then the solution you're going to put into it, which happens to be sulfuric acid. You open the tap and you discharge some liquid into a beaker until you have the solution at the 0 mark. And then, sorry, you should have mentioned you fill the burette using a funnel, okay, a funnel again, and remove the funnel before you start, and you're ready to go. And finally, how would you run a titration? Do you know that? The salient points are: open the tap and swirl the conical flask. You swirl it because you're going to be getting a temporary color change, and when you swirl it, the color goes. So by swirling it, you'll find out when the color change becomes permanent. And that's what you're after, right? The first permanent color change there. Somewhere just before the end point, you stop and you wash down the inside of the flask with deionized water. Do you remember all this? I've just done with you now. Okay, you wash it down with a little deionized water because of any splashes on the inside of the flask. You want them included in the reaction, and that's very important. And finally then, you run the last few drops until you get your first permanent color change. Note the reading and repeat the titration at least twice. Okay, and you're taking an average, as I mentioned to you already. Now I'm going to go through the calculation with you now next. We're looking for the concentration of KOH. They want the percentage purity here, so here's what we're doing next then. Okay, M1 V1 over N1, M2 V2 over N2. I'm looking for the concentration of KOH, so I'm putting that in here. And I know the concentration of sulfuric acid, H2SO4, so I'm putting that here. Now, I call that tagging, and I think it's very important that all of you do this all of the time. And the unknown should be on the left, meaning the one you're trying to standardize, and the one on the right, the standard solution, should be there. Okay, you know the concentration of this, you're looking for the concentration of this, and now you fill out the various pieces. M1 you're looking for. The volume of KOH is right there, it's 25. The number of moles of KOH, back to your balanced equation given to you in the exam, and that's a 2. Equals the concentration of sulfuric acid is 0.1 multiplied by the volume, which is 22.9. 22.9, and all over, and in this case it's 1, yeah, ratio 2 to 1 there, and so you go and solve for M1. Okay, I've done that already for you, and M1 came out to be 0.183. 0.183. Now be very careful, please. 183, and that's moles per liter. Please tag it. It's KOH. Now, are you okay? That's the concentration then of this solution. We now know that in moles per litre. Now, what are we to do if we're to establish what the amount of impurity in that is? Now, I'm stressing again to you, we did not know the concentration of KOH because some of the 2.8 grams included the impurity. It included the dirt. Okay, so we need to realize that that's why we're doing this. That's the amount of that's pure. So what do? You must now go, you're now on your roadmap. Does that sound familiar? You're going to convert this concentration into other ones now. You'll now go to grams per litre, okay? You'll multiply that by the MR for this. Potassium is 40, okay? 40. Oxygen is 16, and hydrogen is 1, okay? So you're 57 there. You multiply by 57. And when you do that, 57, you're going to get an answer of 10.44 grams per litre. 10.44 grams per litre KOH. Okay, I multiplied by the MR for that. The tag is very important now. If you have the wrong tag, you'll have the wrong MR, and of course, you're going to go wrong with that. Now, where are we going from there? Do you know? Now, don't worry about me here now. I'm drawing boxes for you. Do you know what they represent? They should represent something fairly structured in your life now. They're the 5 concentrations that you need to know. Moles per litre, grams per litre, parts per million, percent WV, and grams per flask. And that's the guy we want now. Grams per flask. The flask we have is 250. That's why I wrote 250 on that. The next time you see this, that could be 500. Okay, so you write it down to remind yourself. So you're dividing that to get grams per flask. And I got for that, just to speed things up, I got 2.6 grams per 250. 2.6 grams per 250 centimeters cubed KOH. Okay, grams per flask. And so you have it. There's your answer. For the moment, that's what we're looking for. Now, relief, I hope, relief, that's smaller than that. If for any reason that was bigger than that, you've made a mistake. Now, there's the pure KOH, there's the impure KOH, so you know the amount of impurity present. And that's exactly what you wanted there. There is no more to it than that. And that's ultimately what we have to do. Okay, so there is the mass of KOH in that flask. And it's less than that. Now, that's a check every time. It's very important you realize that. Okay, now do I need to recap on anything there? Are you okay? That's fairly standard stuff now, except please stop cutting corners. I have great value in this. I've seen over the years so many people screw up here, making silly mistakes. They don't bother with this. They don't see the advantage in this. The advantage is it eliminates error. And that's where I'd like you to be coming from. That if you do that, you'll do very well for yourself. And that's most important, you work your way through that. 2.6 then is the mass of that there. Now, we need to work out the amount of impurity. We have to make up this table now for impurity as follows. I hope it's all right with you. And I'm just dealing with this. Can I just check my camera to see, are you picking up on that okay? I hope it's all right with you. Yeah, I think that's okay. You'll be able to follow that all right. I think it's fine. Okay, now just can I do this bit with you here? I want to make sure it's all right. Okay, so I'm going to follow it through as follows, right? First of all, now what we have is mass of impure KOH is 2.8 grams. Mass of pure KOH is right there, is 2.6 grams. So mass of impurity is equal to 0.2 grams. Now let me just see, is that going to improve things any bit for you, just in terms of what you need there? All right, mass of that, okay? Very, very important that you'll be working with that and that you have a sense of what you're doing with that. It's most important you can actually see what I'm at there, okay? I think it's okay, yeah, just what you're doing. So that's the mass of the impurity, right? Okay, now what I'm going to do next is the percentage. They've asked for the percentage impurity. And the percentage impurity is equal to, now do you know what it is? The percentage impurity is the mass of the impurity over the mass of the whole lot by 100. That's a standard statistical measurement. What is the percentage boys in the class? It's the number of boys over the total number in the class, including boys, by 100. So the percentage impurities, I'm not writing this out now, but I'm telling you what it is. It's the mass of the impurity itself, 0.2, all over the total mass, which is 2.8, multiplied by 100, and that would be your answer, okay? That would be the answer that you're looking for. There's nothing more to it. It comes out as 7.14%. 7.14% is what you're looking for. Now, I'm more interested in method, I'm saying this to you, than anything else. I'm much more interested that you have a sense of how to do the question rather than the answer. I really don't have much interest in just doing another question with you and saying that's all there is to it. Now, are you looking at that okay? And do you think it's all right? I'm conscious now that, you know, everything on the left-hand side of your screen there is available to you in print. It's available to you in print. Now, I'd strongly recommend that sometime in the next few days that you take one of these questions and you engage like that with it again and see are you getting the same result. Now, you need a calculator and you need your periodic table on page 79 to get the MRs and things like that, but that's the method. By the way, if they had asked you for percentage purity, okay, percentage purity, you'd be taking the pure stuff, 2.6 over 2.8 by 100. Or if you like, you could subtract that from 100. That's the percentage impurity. So the percentage purity is the remainder of the 100%. Are we okay with that? And that's what they'd require, nothing more, nothing less than that. Okay, I'm going to scrub that now. But I'm very keen that you would start to develop a technique for handling these questions and that it wasn't just another calculation, that you had a strategy for it, okay? Good. So that's it. And that's that question. And finally there on the bottom of the screen and in your copy you have a question on vinegar, which I better do with you. A very popular question in Leaving Cert, and we better be clear on that because it is the method now more than the solution, I keep saying to you, and I hope you're okay with this. I'm going to read it for you now. I hope it's all right that I can go through this. All right, as follows. You're given a balanced equation of ethanoic acid. By the way, that is the active ingredient. CH3COOH is the active ingredient in vinegar. Okay, that's ethanoic acid, the active ingredient in vinegar. And that's very important, right, that we're dealing with that. So it reacts with sodium hydroxide and gives you this. And you're given the equation now. Relax, and the knowledge will be given to you, right? And this certainly is on your course. I've told you that those two chemicals are not on your course. If this comes up in the leaving cert, you're going to get hydrochloric acid and sodium hydroxide. I just changed it for a bit of variety so that you're able to adapt. And it's very important you can adapt. This one here then, 50 centimeters cubed of vinegar were diluted to 250 centimeters cubed with water. 25 centimeters cubed of this solution required 21 centimeters cubed of 0.2 molar sodium hydroxide for neutralization. And you're told to calculate the concentration of the ethanoic acid in the vinegar in moles per litre and in percent WV. Now, if you have this copy in front of you, I've already corrected in class. That piece might have been missing and it needs to be corrected. Will you just check, please, that that is written on the copy that you have? It was an attachment, okay, that you have already. You got it in class from me. Okay, the very last class we had here in Bruce College, you got that from me. Okay, so please will you make sure you've corrected that, that's the question you have there. Now, that's a very bare question again. I'm simply putting emphasis on the calculation here. But there'd be a whole procedure involved here and ask you how you did certain things. Now, I'm going to animate that again for you in the hope that you would see that there might be a method here that you take on board. Somebody took 50 centimeters cubed of vinegar. I'm drawing a bottle of vinegar. Here's a commercial bottle of vinegar, okay? There's your vinegar, commercial vinegar, okay? And you would not put a pipette into that, okay? You'd put it into a beaker first. The vinegar, that vinegar, just pour into a beaker and you pipette it out of there then to get, you want 50 centimeters cubed, okay? You could pipette it straight into your volumetric flask, okay? You could pipette it straight into your volumetric flask. Some of you might like to pipette vinegar out of that into another beaker so that you had exactly 50. That'd be a pipette by 2. Okay, we have 50 centimeters cubed there. So I'm talking to you about 2 fills of the pipette in here. Okay, I'm just going to illustrate it like that now. 2 by 25 centimeters cubed of vinegar into that. Are you okay? And then you'd make it up to the mark with deionized water with all the usual panache that I said to you already. You'd wash the flask with deionized water. You'd wash the pipette twice. You'd use a pipette filler. You'd fill it vertically until you had the meniscus at the mark on the pipette. You would discharge it into the flask, okay, or else into a beaker and pour the contents of the beaker in there, whichever you prefer. Doesn't really matter, but that's what you do. Some people would like to pipette 25 here into another beaker and then a second 25 into a beaker and then pour the lot in there. That's fine. But be clear as to what you're doing, that exactly 50 centimeters cubed gets in here. That's vitally important, okay? Now, do you all know then, if you put 50 centimeters cubed into this flask and you make it up with water, you're going to have CH3, COOH in here. You're going to have that in here, okay? And you're going to be looking for its concentration, of course. That's what we're doing. And do you know that this particular one here, this is ethanoic acid as well, CH3COOH, the original commercial vinegar is there. Do you know that that concentration would be 5 times greater? You have diluted the original vinegar by 5 by putting 50 into 250. 50 and 250 is 1 in 5, so that's 5 times more concentrated than that. Why have I written that there? Because when I do the calculation, it reminds me that when I get the concentration of this in the titration, I'll need to multiply by 5 to get the concentration of that. Now, those little plans are very valuable. You tend to forget these things or overlook these things, and then they're very costly marks. Because, you know, everybody does this question. You need to score high in it. I'm not interested in you doing question 1. I'm interested in you doing question 1 with the idea of getting full marks in it or very close to that. And that's vitally important here that you work through that, okay? So that's 5 times more concentrated than that. I'm reading on for the moment. 25 centimeters cubed of this solution required 21 centimeters cubed of sodium hydroxide. And you're given that as a standard solution. Now, folks, do you realize what's happening then? This is again the titration. There's my burette. And there's my conical flask. It says 25 centimeters cubed of this solution, meaning the vinegar. So this went down here. 25 centimeters cubed of CH3COOH question mark. We're looking for that. And it was titrated against It was titrated against sodium hydroxide. Sodium hydroxide is up here. Okay, and its concentration happens to be 0.2 molar. I'm putting an asterisk on that because I know its concentration. I have a question mark on this because I'm looking for its concentration. How do I know that that went up here and this was down here? And the answer is because 25 means you pipetted it. As it happens, you could have a 20 ml pipette as well. We nearly always use 25. The 25 is always downstairs. The odd number, 21. 21.0 centimeters cubed could only have come from a burette. A burette will give you any reading between 0 and 50 centimeters cubed. So that tells me that was upstairs and that was downstairs. Now, when I demonstrated this in the lab to you, I had them the other way around. And I'll talk to you in a moment about indicators, even though I've told you there's another part of your course that deals with indicators, and that's the way it should remain. And I think that's rather important that we'd work like that. So there you go. There's my plan. I think I've noted everything now at this stage. It says 0.2 sodium hydroxide for neutralization, and it says calculate the concentration of ethanoic acid in the vinegar. Now, they'd be more precise than that in the leaving cert. They'd say in the original vinegar or in the household vinegar, or in the diluted vinegar, whichever one they want you to have. Now, that would be the diluted vinegar, whereas that is the household vinegar. Please read the question, okay? Very important. And so that's exactly what we're going to do. I'm going to do the calculation with you now. M1 V1 over N1 equals M2 V2 over N2. I've asked you to tag it, please. Very important. We're looking for the ethanoic acid, so CH3COOH is there. And the sodium hydroxide, the NaOH, is here. Are you okay with that? Very important now that you're okay with that, right? I'm looking for M1. Good. The volume of that I get from my diagram, it's 25. The number of moles of ethanoic acid, I'm given this ratio 1 to 1. I'm given that that's 1. Okay. The concentration of the sodium hydroxide, we're given 0.2. The volume is 21, that's the mean titer, the mean titration reading, and that is also 1, the ratio 1 to 1, there you are, 1 to 1. So you solve for M1, M1 is equal to, and you go and solve for that, and I got 0.168, 0.168 moles per litre. Now, don't worry. Are you okay? You could call that molar if you're capital M if you wanted. It might be written as 0.17, okay? But that's fine. 0.168 is what I've got there. All right. Now, do you know what you're doing from here, I wonder? Because this is the whole point in this. Okay. They've asked you for the concentration of the vinegar in moles per litre. Okay. This is tag, please. CH3COOH, right? And I'm writing in here, in the diluted vinegar. In the diluted vinegar, please. Very important. Now, these statements are important. They give you a heads up on what you're doing, and you tend to communicate it much better, and you don't make mistakes. That's the concentration of the ethanoic acid in the diluted vinegar. Now, they might have asked you that in the leaving cert question. I didn't ask you there. I just said in the vinegar. So that's the vinegar. Okay, just be aware of that now. So you know immediately you have to multiply by 5 to go from there to there. I've already reminded myself up there. So you multiply that by 5 and you have your answer. Are you okay with that? And I got 0.84 for that. 0.84. 0.84 moles per litre CH3COOH in the original vinegar or the household vinegar, okay? Original, I'll put it here. In the original vinegar, okay? Now, please, you tend to leave out a lot of the qualifying stuff, and that, in my opinion, is dodgy. You'll make mistakes very easily, okay? So you're there, you have moles per litre. And they want percent WV now. You're on your roadmap. Here I go again. There's your moles per litre. There's your grams per litre. There's your percent WV, parts per million. We were using that a while ago. Do you remember? You're going to go that way now. You're going to go from there to there. Are you okay with that? No, this should be bread and butter to you now. You should be practicing this all the time. The same stuff repeats itself over again. So you have moles per litre. So you go to grams per litre now by taking the 0.84 and multiplying it by 60. Okay, 60. 2 carbons. I'll check that. 2 12s. 24. 2 oxygen, 16 is 32, and 4. 4 and 4 is 8, 10, that's right, it came out as 60, right? Will you be careful now, please? You'll be raging with yourself if you make a mistake like that, all right? And that came out to be grams per litre, 50.4 grams per litre. Okay, that's equal to 50.4 grams per litre CH3COOH, okay, in the original course, yeah? And you don't want grams per litre, you want percent WV, so you want grams per 100. So that's equal to 5.04 grams per litre, okay, which is equal to 5.04% WV. And please tag it CH3COOH, right? Now, there's your answer. There is your answer, the percent WV. Now, please, I'm presuming at this stage that I've done this several times, you know where you're going. That's what I called your roadmap. You went from moles per litre to grams per litre to percent WV. Do you know that percent WV is grams per 100? Sorry, look at that for a slip of the pen there. Okay, folks? Grams per 100 centimeters cubed. Grams per 100 is percent WV. And that's it, 5%. And that's what a normal commercial vinegar is about. That's very good. Now, we've come to the end of this section now, and I'm very keen that you would be willing to pause and go back on this and say, I can handle that. I have a method. Now, I have done nothing in asking you, how did you do that, or how did you do this, or how did you run the titration? In every year, they'll ask you one of the methods as well. The calculation is only part of it, but you have great control over it. Now, please, take my tips now, please. The animation, in my opinion, is a good idea. It gives you a sense of where everything else is. The next time you see that, that could be up here, and this could be down there. How will you know that? The 25 will tell you, or the 20 will tell you it is down here. And the odd number, the 22.4, the 21 or whatever, has to be in the burette. Okay, and you work on the basis of that. Please tag everything. Make sure you put a tag, number, unit, and tag. Multiply by the MR, and you get grams per litre. Okay, and that was in the original. You had to multiply, as you know up there already, that's what you had with that, and that's very important. You're working with that. Now, is everybody all right in dealing with that? That's what we're doing there. That's the diluted vinegar, and the original vinegar. Sorry now, but I'm sure I need to just point out to you there that you're multiplying by 5, aren't you? For that you are. You have to multiply that by 5 to get there. Look, I have that there. It's very important. Now, I'd like to think you'd lay it out like that in the exam, and that's very good. Now, folks, in the next unit, I'm doing your March exam question. Okay, question paper. I need a question paper, which I'm going to go through the full paper. We're going to discuss every question. I have those scripts all the time. We'll return them in due course to you, but I'm just saying to you, we need to go through the marking scheme, and we'll go through every question. You need to have the question paper in front of you when I start again. All right, so take care with that now.